Q6990. The indicated liftoff airspeed for short-field takeoffs in a particular aircraft will normally be A. The same as for soft or rough field takeoffs. B. Greater than for soft or rough field takeoffs. C. Greater under tailwind conditions than required under headwind conditions. The correct answer is B. During a short field takeoff, the objective is to minimize the ground roll and achieve a rapid climb to clear obstacles at the end of the runway. In order to accomplish this, the aircraft needs to generate sufficient lift to become airborne as quickly as possible. Compared to soft or rough field takeoffs, short field takeoffs typically require a higher liftoff airspeed. The higher airspeed helps to generate more lift, allowing the aircraft to become airborne in a shorter distance. By increasing the airspeed at liftoff, the wings can generate the necessary lift to overcome the aircraft's weight and any additional drag caused by the short field or obstacles. Additionally, the higher liftoff airspeed for short field takeoffs ensures a greater margin of safety and provides better control during the initial climb phase. The increased airspeed provides a greater margin against stalling and allows the pilot to maintain positive control of the aircraft as it transitions from ground effect to climb. In regard to the third option, the liftoff airspeed for short field takeoffs is not necessarily dependent on tailwind or headwind conditions. The airspeed required for liftoff in a short field takeoff is determined by the aircraft's performance characteristics and the conditions of the runway, not the wind direction. Therefore, the indicated liftoff airspeed for short field takeoffs is typically greater than for soft or rough field takeoffs, ensuring a swift and safe climb to clear obstacles and minimize ground roll. 7003. Immediately after takeoff, a downwind turn close to the ground is not good practice because it A. Decreases the rate of climb significantly. B. Causes an increase in the speed at which rotor stall occurs. C. Increases the hazards involved should an emergency landing become necessary. The correct answer is C. Performing a downwind turn close to the ground immediately after takeoff presents several risks and hazards. One of the primary concerns is that it reduces the available options for an emergency landing. In the event of an engine failure or other emergency shortly after takeoff, it is crucial to have sufficient runway or open space ahead to safely land the aircraft. By initiating a downwind turn close to the ground, the pilot limits the available landing options and increases the likelihood of having to make an emergency landing in a constrained or unsuitable area. Furthermore, a downwind turn close to the ground can increase the aircraft's ground speed relative to the surrounding air. This can result in a higher ground speed during the turn, which may exceed the aircraft's stall speed. Exceeding the critical angle of attack or stalling the aircraft close to the ground can lead to a loss of control and a potential crash. Therefore, it is important to avoid downwind turns close to the ground immediately after takeoff to maintain a safe airspeed and reduce the risk of stalling. In contrast, initiating a turn into the wind or making a crosswind turn after takeoff allows for better control, reduces ground speed, and provides more options for emergency landings. Turning into the wind helps increase the aircraft's climb rate, enhances control authority, and improves the margin against stalling. Therefore, due to the increased hazards and reduced emergency landing options, it is not good practice to perform a downwind turn close to the ground immediately after takeoff. 7051, which would likely result in a slipping turn. A. Not holding bottom rudder in a turn. B. Increasing the rate of turn without using rudder. C. Increasing the rate of turn without increasing bank. The correct answer is B. To understand why this is the case, it's important to first clarify what a slipping turn is. In aviation, a slipping turn refers to a situation where the aircraft's rate of turn is greater than the desired rate for a given bank angle. This can result in the aircraft's nose pointing towards the inside of the turn and the aircraft slipping or sliding sideways through the air. When an aircraft is in a coordinated turn, all three primary flight controls, the ailerons, elevator, and rudder, work together to maintain balance and coordination. During a turn, the ailerons are used to bank the aircraft, the elevator controls the pitch attitude, and the rudder is used to coordinate the turn and counteract adverse yaw. In the case of increasing the rate of turn without using rudder, the pilot is not applying the necessary rudder input to coordinate the turn. This means that the rudder is not being used to counteract the adverse yaw, which is the yawing moment that occurs due to the difference in drag between the up-going and down-going wings during aileron input. When the rate of turn is increased without using rudder to coordinate, the aircraft tends to slip in the opposite direction of the turn. This happens because the increased bank angle creates more lift on the outside wing, which leads to a yawing moment towards the outside of the turn. Without proper rudder input to counteract this yawing moment, the aircraft slips sideways through the air. To maintain coordinated flight and prevent a slipping turn, it is essential to use the rudder in conjunction with the ailerons to coordinate the turn. Applying the appropriate rudder input in the direction of the turn helps to counteract adverse yaw and maintain proper balance and coordination throughout the maneuver. Q6983. What will cause the nose of an aircraft to move in the direction of the turn before the bank starts in a turn entry? A. Rudder being applied too late. B. Rudder being applied too soon. C. Failure to apply back elevator pressure. The correct answer is B. During the entry to a turn, it is important to coordinate the aircraft's control inputs to ensure a smooth and coordinated maneuver. This involves using the ailerons to bank the aircraft, the elevator to control the pitch attitude, and the rudder to coordinate the turn and counteract adverse yaw. When the rudder is applied too soon in the turn entry, it means that the pilot has applied rudder input before initiating the bank with the ailerons. This premature rudder input causes the nose of the aircraft to move in the direction of the turn before the bank starts. The reason for this is the aerodynamic effect known as adverse yaw. When the ailerons are deflected to initiate a turn, the downward deflection of the aileron on the outside wing increases the lift and drag on that wing. At the same time, the upward deflection of the aileron on the inside wing decreases the lift and drag on that wing. The difference in lift and drag between the two wings creates a yawing moment, which tends to yaw the aircraft in the direction opposite to the intended turn. This adverse yaw can cause the nose of the aircraft to initially move in the direction of the turn before the bank starts. To counteract this adverse yaw, the correct technique is to apply rudder input in the direction of the turn, but at the appropriate timing. The rudder should be applied after initiating the bank with the ailerons, ensuring that the aircraft is properly coordinated throughout the maneuver. Therefore, if the rudder is applied too soon in the turn entry, it will cause the nose of the aircraft to move in the direction of the turn before the bank starts. Q6981. During level turns in side-by-side airplanes, which is characteristic of student performance. A. Diving during right turns because the nose appears to rise during entry into these turns. B. Diving during left turns because the nose appears to rise during entry into these turns. C. Climbing during left turns because the nose appears to descend during entry into these turns. The correct answer is B. To understand this, let's examine the aerodynamic forces and the visual perception during level turns in side-by-side airplanes. During a level turn, the aircraft experiences a combination of centrifugal force and gravity. Centrifugal force acts horizontally and pushes the aircraft away from the center of the turn, while gravity acts vertically downward. To maintain a coordinated and level turn, the pilot needs to adjust the aircraft's attitude and control inputs. In side-by-side airplanes, the pilot's seating position and the visual perspective can create an optical illusion known as the leans. This illusion occurs when the pilot relies solely on visual cues to determine the aircraft's attitude. In a left turn, due to the position of the pilot and the visual perspective, the nose of the aircraft may appear to rise during the entry into the turn. This can create a perception that the aircraft is climbing or pitching up. As a result, student pilots may instinctively react to this perceived nose rise by pushing the aircraft's nose down, causing a diving motion. In contrast, during right turns, the nose may appear to drop or descend during the entry into the turn. This can create a perception that the aircraft is descending or pitching down. However, the correct response to this visual illusion is to apply back pressure on the controls to maintain level flight. Therefore, it is characteristic of student performance to experience diving during left turns because the nose appears to rise during the entry into these turns. This is due to the optical illusion caused by the pilot's seating position and visual perception.